Sketch the graph of y equals negative x minus 3 to the power of 4 plus 16 on the set of axes provided. Clearly label any axial intercepts with their coordinates. So the first thing we can do is we can inspect the rule and we can see that this is a Quartic graph, and that the form that it's in indicates that it's going to have this shape here. It's going to be in a turning point form, and it's negative, so it's drawn upside down because of the negative symbol out the front, which is a reflection over the x-axis. So now that we know the general shape of this graph, we have to find the y-intercept and the x-intercept. So the y-intercept occurs when x is equal to 0. So in the rule, we're going to have y is equal to negative 0 minus 3 to the power of 4 plus 16. And that means that y is equal to, so this is negative, and then it's minus 3 to the power of 4. So when we do minus 3 to the power of 4, we get 81 with the negative sign out the front. So we have negative 81 plus 16. And if you evaluate that, it's negative 65. Therefore, we have a y-intercept at 0, minus 65. Next, we find the x-intercepts of the graph, and this occurs when y is equal to 0. So in our equation, we're going to have 0 is equal to negative x minus 3 to the power of 4 plus 16. Our job now is to solve for x, and because it only appears once in the equation, we can simply undo this. So the first thing I'm going to do is I'm going to add x minus 3 to the power of 4 to both sides of the equation. So that means that the next line will be x minus 3 to the power of 4 is equal to 16. If x minus 3 to the power of 4 is equal to 16, that means that x minus 3 must be equal to plus or minus the fourth root of 16. Cleaning that last line up a little bit, we'll have x minus 3 is equal to plus or minus, and the fourth root of 16 is 2, because we have 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's plus or minus 2 on the right-hand side. And now if we add 3 to both sides of this equation, we'll get x by itself. And that will mean that x is equal to 3 plus or minus 2. Therefore, there's two x-intercepts, one at 3 subtract 2, which is 1, 0, and the other being at 3 plus 2, which is 5, 0. On the set of axes, we need to draw the general shape where our key features are in the right positions. So this Quartic is going to look something like this. So just like a parabola, we can look at the negative 3 here and the 16 here to determine the coordinates of the turning point. So for this Quartic, this turning point is located at positive 3, 16. The y-intercept down here was at 0, negative 65. And these x-intercepts were at 1, 0, and this one was at 5, 0. So that's the graph of this Quartic. On this slide, we've got a computer to generate the same graph of the Quartic, and as you can see, all the key features remain the same.